All right, so the first few are just testing you if you know the formulas, which I'm going to give it to you in just a second. So there's law of sine and law of cosine. So basically, we're going to start with a question like this, and we need to find all the sides and all the angles. But notice there's no right triangle, right? No right angle anywhere. So you have to do law of sines. So don't do Pythagorean theorem. You can only do that if there's a right angle. Okay. All right. So let me give you all the notes you're going to need. The camera's being weird today. Okay. Okay, so law of sine. So there's three cases. So case one means you have one side and two angles. So as long as you have that, you are allowed to use law of sines. One side and two angles are known. The book calls these ASA and SAA. Case two. The two sides and an angle opposite to one of those sides. Okay, case three. Two sides and the angle not opposite to those sides. Okay, case four. Three sides and no angles. Okay, so case one and case two are going to be law of sines. Case three, case four, you have to do law of cosines. But let's start with the law of sines here. The formulas and definitions. So for a triangle, with sides ABC and opposite angles, capital ABC, respectively. So I'm just going to draw a general triangle. It's not going to be pretty, but so pretend you have some triangle that has no right angles, right? So capital A is over here, capital B, capital C. opposite to those sides, you got lowercase c, lowercase a, lowercase b. So opposite, opposite. See how we set them up? So always think about that when we create the law of sines. So the main formula is this one. So you say sine A over its opposite side, little a. That ratio is equal to sine capital B over its opposite side. And that is equal to sine capital C over little c. And you can take the reciprocal all three sides of these three equations and just put them upside down if you need to. Now this step is not necessary, but I like to create two of them. So I can use the one that's a little easier, or let's say I need to find a side, then I'm going to use the ones where the sides are on top. That way I can do less algebra. If I need to find an angle, then I'm going to use the top one. Of course, it doesn't matter. It's just a preference. Okay. All right. So I'll make a little note here just to help you out. Use formula one, to find angles. Use two to find sides. So basically, you're going to decide how to set this up. Depending on the problem or what you're given, you'll set up an equation like this. Then you'll find the missing side. Okay. And I'll wait a bit because that was a lot of writing. And we'll start the examples. No, wait just a moment. Okay, you turn the page. All right. So example one, I believe this is from the homework. Let me share that again. Let's see here. No, it's a different one, but similar. That's okay. We'll probably do both anyway. Okay. So pretty much for the most part, the entire chapter just solved triangles. I don't think there's anything else really. Of course, some word problems. But I'm not going to give you anything too crazy. So what they give us in the problem is capital A, capital C, lowercase c. I'm really bad at lowercase and capital C. So if you have a better way to write it, or if you want to put a little bar on top, that's whatever. It's up to you. Up to you. All right, so we don't have these pieces. Sometimes they give you a triangle drawing or something. So if they were to give us a drawing, it'd be something like this. We don't know little b, we don't know little a. We got capital C at 100 degrees. Okay. Alrighty, so we should know as soon as we have two angles, we technically can find the third, no problem, right? I think we've done that before. So the first thing you should do is just check, okay, if I got two, just go ahead and find the third one. Okay, so B would be equal to 180 degrees minus the other two, because the three need to add up to 180. So that would be 20, right? So I'm going to box the ones that we found so I know which ones were not given. So now we have capital B. Okay. So you need to use law of sines. This is going to be, this is case one, I think. Let me see. One side and two angles. That's case one. So if I want to find a side, what I recommend is say little a over sine a, because I want to solve little a first. Set that equal to something that already has both pieces. So c over sine c. Since I have both of those, then I can solve for the missing piece, and I have capital A. So the only unknown is little a. So you can only solve it if, of course, I'm sure you know already, when you're solving equations, you can only solve one unknown. If you have two unknowns, then you need two equations, but we're not doing that. So just isolate what the piece you don't know. So I'm going to multiply both sides by sine A. That would get me to here. So plug in what we know and we're good. I'm going to use my calculator though. So 4 sine of A over sine of 100. So that will be little a. Any questions on this algebra step that I skipped here? Any question on why we set it up this way? Because you need to make, you're going to decide this on your own in the middle. Okay, let me go grab my calculator. 1 second. Okay. I don't know if I'm in degrees. Let me check. Yep. Okay. 3.51 round to 2 decimal place. 3.5. Oh, actually, it might be 1. Let's do the 1. So we got a little a. Box that because we didn't have it. Now we just need a little b and we've solved the triangle. Okay. So do the same. So this is the first step here. Second step. Third step. So create another equation like this. So I want to find a little b. So I'm going to choose this one, little b over sine b. Set that equal to the one we already know that we had from the beginning. Since it's a whole number, oops. Should put this. There we go. Okay, so plug in everything. Well, actually, just isolate b. So I multiply both sides again by sine b to cancel this denominator. So you get sine c sine b over sine c. Okay. All right. So plug in everything we know. That'll be 4 sine of 20 over sine of 100. So at that point, it's calculator. So 4 sine 20. If you're not gonna use the fraction button, put parentheses on everything on the bottom. 1.3938. So around to 1.4. Okay. Any questions on any of those steps? Okay. So far, it's not too bad, is it? Six. Yeah, people tend to do a lot better in this chapter. So I'm hoping you all do fine when you get there. I know some of you might still be focused on test 2. Okay. Example 2. Okay, so this time I'm just going to give you the information they give me. So let's see here. Well, 1 second. Yeah, let's just do one more of those of this type. Okay, so B is 17 degrees. This is question 6. Nothing else is given. Okay. So right now, I can't find any of the A stuff. Well, I can't find little a because I need capital A, right? Whereas when you build that equation, you have sine capital A over little a. B, I can find little b because I have capital B. So the first thing you should do, like we said before, is find the missing angle by subtracting from 180 degrees. So just 180 minus those two, and you'll get the third. So it will always be that way. 28. The missing side is 28. So this was not given to us. So I want to find a little a, so I'm going to equate it to the one that has both parts, just like before. So C over sine C, multiply both sides by sine A, you'll get C sine A over sine C. Plug it all in. 41 sine of 28 degrees over sine of 135. So 27.2. I think they round to 2 decimal places, so 27.22. Little a, 27.22. Okay, so now I'll repeat the process. Find the side B, and that's it. So B over sine B. I keep setting it equal to the one that has the whole numbers or the original that we had because there's no rounding and it was given to us, so I know it's not messed up. If let's just say we made a mistake along here and then we use that over here, then this will be wrong. But I know this is right, so that's why I keep using the same one. Doesn't matter though, but there's more accuracy here. Shoot, let me write the letters first. Does not matter. C over sine C. Solve for B. That'll be C sine B over sine C, which is 41 sine of 135, 17. Sine of 17 over sine of 135. Oops. So 16.95, which is, yeah, around to 16.95. Okay. Any questions on this problem here? Yeah, calculator is in degrees. So make sure if they're, I mean, I think for the most part, chapter 9 will be in degrees, but if you see them using degrees, make sure you switch to. Okay, so those are two examples for case 1. So there's something you need to worry about. If you're only given one angle, I mean, they can be, but I don't think they will be on the homework or the exam. At least not for chapter 9. Okay, yeah, so if you're given two angles, then you're guaranteed to know that a triangle exists. So for example, right here you see we have two angles, therefore there can only be one more to form a triangle, right? I know that sounds silly, but that's what you know if you're given two angles. See, here they gave us an angle and an angle, and they gave us a picture. So obviously I know there is a triangle, it exists. So if the question is case 1, meaning you have two angles given to you at the start, then you don't have to think about is there a triangle or is there two triangles. So the first few questions are just straightforward, what we just did. Same thing, nothing different. Question 9, though, this is where they change. We only have one angle. So it's possible that when you're trying to solve the other angles or find them, you're going to get an error. And if you do, then there is no triangle and you're just going to write impossible for the homework. Okay. The difficult scenario is that there's two triangles that exist. So this is a little annoying, but we'll go do it together. Because when when you're solving for angles, remember how when you do sine inverse, you get two solutions, right? By subtracting from 180. So you need to check if both the solutions work, given given this angle, right? So if let's say I solve for B and I find this one and this one, then I say, okay, well, if I add 54 degrees to this one, do I still have a triangle? Yeah, that's less than 180, so cool. This plus 54 is still less than 180, so great. Since they both work, then I have two triangles. If one of them doesn't work, then I only have one triangle. If neither work, or if you get an error, actually, if you get an error on your calculator, you just stop and say, okay, there's no triangle. Okay, so the only time you have to worry about 1, 2, or no triangles is when you're given a question that only has one angle. Okay. Okay, so let's do the one that has no solution. Number 9, I guess. Steps here. First part, second part, third part. Okay. This is case 2. A is 100 degrees. Little a is 175. Capital B, little b is 250. Capital C and little c are not given. This is all we are given. So notice how we're missing one angle. So that's a hint. Since you only have one angle, that's a hint that it's case 2. And you have to have an opposite side to the angle you were given in order to do law of sine. So like if I had a little c instead of little a, then I can't do anything. You would have to use a different method, but this is case 2. So I'm going to try to find capital B, see what happens. So I'm going to use sine B over little b. I'm going to set it equal to sine A over little a, because I know these two are given, so I can just use that right away. So solve for B. Right? Multiply both sides by your lowercase b, and then do the inverse of both sides. I'm going to show an extra step this time. So capital B will equal sine inverse of 250 sine of 100 over 175. So when you're doing this in your calculator, you should get the error. Since we know there is no triangle, that's what we should get here. So second sine inverse 250 sine of 100 divided by 175. So I get my error. So there's no solution. There is no triangle. So at this point, you just stop. Okay. And the homework, they want you to write impossible for all the solutions. That makes sense? Okay, the one with multiple triangles or two triangles is the one out that this is the harder one, I guess. Let me get the book out so I can show you. The book has better drawings than what I can do. Oh, open the wrong one. It was chapter 8, that's why. Okay. No, that's not right. Oh, here we go. Here we go. Let me switch the camera. Oh, this is your textbook. Let me find the example where you have two triangles. There's videos in here too. I'm sure you already know that. Okay, where is it? Given two angles, that's case one, the easier one. We did two of those. Okay. The ambiguous case, here we go. Find a nice picture. I think it's just this one. Okay, where is it? Here. Okay, can you see when I open up the picture? You see where it says acute, no triangle or one triangle? Can you guys see this? No, I'll just cut it out since no one's responding. All right, so case 2. Let me zoom in here a little bit. Okay. So if you have 2 triangles, I'm gonna try to make it a little better. Super tiny. That's not what I want. You can see right here, this piece will either swing out or swing in. So if it's not long enough, then you have no triangle. That's where you're gonna get the error. And if it is, then you'll probably get the one triangle solution. Now, if you have this guy, keeps showing me the same one. Oh, here we go. This guy here, it can either close here. So the A side can swing inward or swing outward. So you have 2 triangles that are formed. So you got to find different pieces here. So as you can see that when you move inward, this angle will be different from this angle, right? So capital B will have 2 solutions. Capital C will change, right? But capital A and this guy will be fixed. So will be most likely, so will A. It depends. Actually, A might change. But capital A and little b on this side isn't moving. The only ones that are moving is this piece here. It flips in or out. Okay, so that's what I need you to remember for the next example. All right, next one's a little annoying and a lot longer, so we only did one step here. Okay. We are given, so example, I think 3, right? Or 4. Okay. So solve the triangle. We are given little a, capital A, little b. I think that's it. I'm gonna call these C1, B1, because those are gonna change while as we find 2 different triangles. So when you're solving for capital B, you're gonna have 2 solutions. So we haven't been checking that because we were given 2 angles to begin with, so it was obvious that we only had 1 triangle, or if we're given a picture, right? Okay, so first thing, let's find capital B. So sine B over little b will be equal to sine A over little a. Solve for sine B. Introduce the sine inverse. So sine inverse of both sides. So B will equal sine inverse of 11.1 sine of 54 over 9.7. Okay. So that'll be 67.78 degrees. So let's hold on a second. 11.4. Oh, put 0.1. Supposed to be a 4. Okay, so let's round to the nearest degree. So that'll be 72 degrees. So this is how you check if you have two triangles or not. You first find one angle. You find the second one by subtracting from 180 like we've done before. Okay. Then you must check if you add these to the original angle that you're given, does that remain to be under 180 degrees? So you say, okay, well, is B1 plus A less than 180? Is 72 degrees plus 54 degrees less than 180? Yeah, right. So that means we're good with that one. Okay. We're good with that particular solution. So now I'll go to the 108 and do the same. Is B2 plus A less than 180? So we should technically do this every time just for the practice, but we didn't do it in the last two examples. So this will be 108 plus 54. Right? Is that still less than 180? That's going to be 162. They're both great. Okay. So since they both work, right, since B1 plus A is less than 180 and B2 plus A is less than 180, then we have two triangles. So you're going to have to find all these pieces twice, I guess. Okay. Okay. Oh, I guess I'll put triangle 2 right here. So A will be the same. Little a is 9.7. We're going to have a different B2, which we found to be 108 degrees. Little b is 11.4. We'll have a different C2 and a different little c2. Okay. So all we really need to do is find C2 again, because we can find the C's no problem, right? Because you can just subtract from 180 to find this guy, and you do the same thing here. So let's do that first before we move on. So it'll be 180 minus a 54 minus the angle we found. So there's C1, capital C1. Now do the same thing over here. 180 minus 54 minus 108, 18 degrees. Okay. We almost have the two triangles completed. Now we just need that C2. Okay. And little C1. So we'll do that on the next page. Guys, okay so far? Okay, let me turn the page in just a moment. Okay. All right, here we go. C1 over sine C1 is equal to A over sine A. Solve for C1. A sine C1 over sine A. Plug in everything from triangle 1, because this is C1. We had, oh man, darts. We had 9.7 sine of 54 degrees over sine of, oh crap. That's not right, I don't think. Yeah, I guess so. They're both 54. Oh well, it's not weird. That happens. $9.7 sine of 54 over sine of 54. This is really just going to be 9.7, isn't it? So there's C1. Let me double check something. Don't think that's from the homework, but maybe. Yeah, that's fine. Yeah, it's problem 10 from the homework. (9.7) was little a, and so was 7.1, I guess. And so was this guy. I did the same thing with C2, but using these angles. Okay. So basically, you'll just have this C2A sine of C2 over sine A. Which will be, those numbers. Yeah, 9.7 sine of 18 degrees over sine of 54. So 3.71. And that's it. So we found both triangles. 3.71. So when if you're solving for the angle, so if you're given two angles, then for sure you have one triangle. If you're given one angle and you're trying to solve for an angle and then you get an error, then you have no triangles. If you have one angle and you're trying to solve for an angle and it works, and then you find the other angle and you test both. If both of them work, then you have two triangles. If one of them fails, meaning when you add it to the other angle and it's bigger than 180, and if it's greater than 180, let's pretend B2 was too big. When I added it to A, then I would still say, oh, I only have one triangle. I wouldn't do two. But if they both work, then you have this scenario. This is the scenario that kind of stinks. Okay. Any questions on law of sines? Okay. Now let's take a short break. It's 12:50. Let's come back at 1:10. And we'll do 8.2 and maybe 8.3. Here it is. Okay. So case two. Is I think the only one that you have to deal with multiple triangles or no triangle. Case four, I mean, if you're given three sides, obviously a triangle exists, right? One triangle exists. So when you're doing case four, it's pretty much a given. You don't have to worry about that. So whenever you're using law of cosines, you won't be worrying about multiple triangles, okay? So we just got to use the new formulas and that's it, okay? Write down the new formulas for 8-2. Okay, so this is the formulas for finding these sides. Number one, little c is equal to, so I solve for all the variables you're going to need. So all you got to do is plug it in. So I made it as easy as possible. To find little c, you need to have the other two sides and angle c. Okay, so you have some triangle, right? A, B, C. Number two, little b. That'll be a squared plus c squared minus 2ac cosine b. Little a will be b squared plus c squared minus 2bc cosine a. All right, let's do the angles next. Again, I solved for everything here. So all you got to do is plug it in. Capital A is equal to cosine inverse or arc cosine of b squared plus c squared minus a squared 2bc capital B cosine inverse of a squared plus b squared minus c squared over 2ab. Capital C is cosine inverse of a squared plus b squared minus c squared over 2ab. Okay, that's all we're going to need for the most part. The first two examples. Well, there are some area formulas. Let me give those to you now. Yeah, I'll do that. So in this section, we're going to be doing the same thing, solving for triangles, missing sides, missing angles, but also area. So in the book, they call it K. K is equal to 1/2 A times B sine C. So depending on what you're given, you'll use one of these formulas. I think they use K instead of A for area because we have capital A as an angle at the moment. Who cares? It's all the same, right? I don't really use these formulas right here, honestly. I prefer Hero's formula, spelled Heron. The only difference is you need all three sides to use it. These you can use with only two sides and an angle. So it's really up to you. So ABC are sides of a triangle, and capital A, B, C are its angles. Okay, let's see if I can fit Hero's formula. A is equal to the square root. Yeah. Sorry. Where S, the square root of S times S minus A times S minus B times S minus C. So you take all the sides and subtract them from S, where S is equal to 1/2 times the sum of all three sides. So can you always use this one for area if you just find the three sides, and you can just do this. I feel like this is unnecessary, but whatever. Who cares? Let's do some examples now. Just a moment. I'll wait for a second. Okay, next page. Example 1. Okay, so notice how this is going to be case 3, I think. Yeah. Okay, so here's the triangle they give us in the, I think it's from the homework. I gotta check. Okay, so this is A is missing, B is missing. Okay. Give me little a and they give me little b. And they give me angle C. That's it. So right here, we know we have A. Need to find these. We were given capital C. Yeah, okay. And these two sides over here. All right. So notice I cannot use law of sines. This is case 3. I don't have any sides that are opposite to this angle, right? Little c is missing. So that's the first thing we're going to find. It's little c, because I think all of the angle formulas, if you look at page, the first thing we wrote down here, I can't find any of the angles without having all 3 sides. So you should always try to find the sides first, okay? Okay. All right, so the formula for C is the first thing we're going to find. It's right here. So that will equal the square root of 2 squared plus 4 squared minus 2 times 2, right? Yeah. Times 4 cosine of 106. So it'd be 4 plus 16 minus 2 times 2 times 2, that's 16 cosine 106. That looks a little better, but either way, I got to do calculator. So you could do that right away if you want. There's no reason to do this in between step. It's just a little easier to plug in. Four plus 16 minus 1, 16.06. Okay. So I got 4.94 for this missing side here. Okay. Then I'll have all 3 sides. 4.94. So now we can find any of the angles. Okay. Let's go ahead and find, I guess, capital B. So capital B, and the formula that I gave you was cosine inverse of, so this is the first thing we did. Second thing, cosine inverse of a squared plus c squared minus b squared over 2ac. So that's cosine inverse of 4 plus 4. Well, let me show the steps. Two squared plus 4.94 squared minus 4 squared over 2 times A times C. There you go. All right. So cosine inverse, I'm going to use the fraction button just to make it a little bit prettier. 2 squared plus 4.94 squared minus 4 squared over 4 times 4.94. 51.12 degrees. Okay, so we got capital B. Now we can find A, no problem, right? We have two angles, so subtract from 180. Third thing we're doing here, solving for, A is equal to 180 minus the other two angles. So that'll be 22.88. Okay. There we go. And that's it. We found all the missing pieces. Any questions on example 1? Just use another page. Okay. Turn the page just a moment. So let's do case 4. So here, all we have is sides. So all we got to do is use the formula to find two angles, and then we subtract from 180, and you will find the third. So just got to do two formulas, and we'll be good. So capital A, the formula is cosine inverse of b squared plus c squared minus a squared over 2bc, which will equal cosine inverse of 2 times 3 times 7, right? See, it's 7 over 5 squared plus 7 squared minus 3 squared. So if you're not going to use the division or the fraction, you got to put the top in parentheses. 5 squared plus 7 squared minus 3 squared divided by the bottom, 2 times 3 times 7. Close the cosine. So parentheses for the top, slash bottom parentheses, and then the cosine parentheses. Oh man, messed up. Let's see. Five plus 7, 5 squared plus 7 squared minus 3 squared. Oh, that should be a 5 here. That gets us 21.79 degrees. So there's capital A. Now do the same thing for capital B using the capital B formula. Write the formula down first. The a squared plus c squared minus b squared over 2ac. So that'll equal cosine inverse of 5 squared plus, actually, 3 squared plus 7 squared minus 5 squared over 2, 3, 7. 3, 7, 5, yeah. Okay. You can use the fraction button if you want. 3 squared plus 7 squared minus 5 squared over 2 times 3 times 7. That'd be 38.21. Okay, so there's the two missing pieces that we found. The final piece is the easiest. C will be 180 minus the other two solutions. Four, it's not 4. So that will be 120 even. So that's case 4. So if you have no angles, you can find them by doing this formula twice and then just subtract from 180 to find the last one. Any questions on example 2? Okay. Well, let me know. Example 3, find the area for, let's find the area for the last example. For the triangle in example 2. So we need the signs to use Hero's formula. So we know that A is the area will be equal to S times S minus A, S minus B, times S minus C, where S is equal to 1/2 A plus B plus C. So that will be these 3 sides here. Three plus 5 plus 7, which is about 7.5, right? Okay. So 7.5 is your S. Subtract 7.5 by every single side. So 7.5 minus the 3, 7.5 minus the 5, 7.5 minus the 7. So at that point, just plug it in your machine and it'll be done. So the area should be about 6.5. I recommend if they ask for area, just do Hero's formula. Okay. Any questions on 8.1 or 8.2? Okay. Well, let's take a look at the homework. I don't think I opened it up this time. But you see how A1 and A2 are similar. You just have different cases, different formulas. That's it. Nothing insane. So this is A2. It starts out with formula questions. Number 4 is basically example 2 that we just did. I think maybe exactly the same or close. Yeah, exactly the same. So we had no angles. You will find 2 angles, subtract from 180, find the third angle. Over here, you have an angle, but no opposite side. You have adjacent sides instead. So you cannot use law of sine. They force you to do cosine. but that's what the section's about, so who cares? That will be case 3. So you'll just be doing case 3 and case 4 over and over again. In this section, you won't have to worry about multiple triangles, but they will quiz you on whether or not you can use law of sines or cosines. So don't forget, when do you use which one? They'll just ask you about that. But yeah, that's pretty much it. Let me look at these word problems. I don't know if I want to have you do that. Let me see. Yeah, that one looks stupid. We'll save these for when we do a review or something. Okay. Save that. All right, so the last few sections were actually almost done with the entire course as far as topics. We have 8.3 through 8.6 left. So the next exam will mainly be solving triangles that we did today, and then vectors. Okay. Okay. Okay, so let's go ahead and just talk about 8.3. Let me pause this for a second. So we just did 8.1 and 8.2. Today's this 28th, so we're technically on schedule, but tomorrow will put us a little behind. So I'm thinking we'll try to do this today here. And then Thursday we'll do this. I just don't know about the review. We'll see how that goes. Thursday might be a longer day. Next week, we could do the review, but then we also have to do the final review. So this weekend and next week, you have to get exam 3 done and then the final done by July 7th. So time is running out. So by July 7th, everything must be done. I'll give you till midnight, of course. But that's technically the day of the final exam. So yeah, so that must be done by then. So what I'm going to do is leave both exam 3 and the final open until the latest possible. So July 7th, I will leave them both open until, let me think. So the final will be open until midnight, July 7th. Exam 3, I'll leave open on midnight, July 6th. Okay. There's reviews already in there for the final. That should help, but yeah. Okay. I'm just trying to give everyone an idea of what's to come because we're almost out of time. If you guys have any questions on the schedule or final, etc. Okay. Let's move on to A3 then. Okay. Vectors in the plane. So in mathematics, vectors are basically look like an arrow, but they have direction and they have a magnitude. Okay. They're very generic in mathematics, but in physics and engineering, vectors represent forces of all kinds. So you can have a force acting on an object in different angles, hence where all the sine, cosine stuff becomes important, right? Because you have a force of pushing an object or pressing down on an object, or pushing it up a hill. All that stuff comes back to angles. So vectors, if you're going down engineering, that route, you'll be very familiar with vectors. If not now, you will be later. You'll be a pro because you're going to be using them all the time. Okay, so I'm going to give you the basic introduction to them. Okay, the vector V has an initial point P. Point P, let's like a D there, P. And a terminal point Q. Find the position vector in the form so I'm going to use this little notation. It's like a little hat, V with this hat thing, means it's a vector. And vectors can be written this way: AI plus BJ, or A comma B. So first example, if they give you 2 points and they ask you to find the vector going through it, this is what you do. So point P, point Q. Okay. One, two, three, four, five. 1, 2. Okay. So we're going to use this in just a moment. If you take, so what you do to find your vector, you subtract the terminal point from the initial point. So for the I component, you do 5 minus 1. For the J component, you do 2 minus 3. So that will be 4 negative 1. So if I use this bracket notation, 4 negative 1 means it's 4i minus 1j. So either notation is fine. So the brackets imply it's ij, or we can just straight up write it. You can add the components together just like you do like terms, like x plus x, y plus y. Same thing. Ready? So -1 will be over here somewhere. 1, 2, 3, 4. So this is the terminal point of the vector. So the vector is just some arrow going this way. Okay, so this is the vector for -1 or 4i 1j. Okay. This could represent a force going in this direction. And we can solve the angle. You can solve for the magnitude. Magnitude would represent the amount of force being applied to an object, right? Like the gravity on an object, you'd have a vector coming down on the object to represent gravity. So the magnitude of the vector, the length, would be the gravity of Earth or something. Okay. And if you're pushing a block like uphill or something like this here, I don't know. Say you got a box. Right, so you're gonna have the force of gravity coming down, which would be one vector. You got friction pushing the block, resisting the block this way. And then you got some, let me put the arrow over here. I mean, we're not gonna do all that much physics here, but this is where vectors are important. You have friction pushing it this way. You have some force pushing it up. And then you have some force opposite to gravity that's keeping the block from going through the ground, right? So all of these forces are vectors. Friction, gravity, the normal force, all that stuff are just vectors of this form. Okay. So if I want to know the magnitude, that would be how much force. And that's really easy to find. Let's do an example 2. So that's example 1, just find the vector. 2 points. But this is what vectors are, okay? It's hard to describe. Find the magnitude. So in math, we just do things in general until we decide to apply it to something. Physics is applying a lot of these ideas to all kinds of things. Okay, so find the magnitude of V. V is equal to -5i plus 12j. That's the ugliest j ever. Okay, so the magnitude will be written this way. It's like 2 absolute value bars on your V. So that means magnitude. The formula is basically the square root of the A component, A1 plus, well, we'll just call it AI BJ. Okay. So if you square each component, this should look very familiar, right? This is the hypotenuse. So what you're technically doing in 2 dimensions, all right, is finding this length, the hypotenuse. Okay, so this right here is your magnitude, your hypotenuse. Okay, so just plug it in and we'll be good. Super easy, right? Plug in the -5 squared plus the 12 squared. Square root this. That'll be 25 plus 144, which is square root of 169, which is 13. So the magnitude of this vector has a length of 13. That's it. So finding the magnitude is not too bad, especially since this is all 2 dimensions. We're not gonna do too many applied problems, but I want you to know the basics for vectors. Okay. Any questions on example 1 or 2? Do you see how to find the vector given 2 points? Given the vector, can you find the magnitude? Okay. All right, so that the homework. The next part is they start adding vectors. It might be easier to look at the homework for this. It's very visual. Okay, so check this out. You have 2 vectors right here. V is going this direction. U is going in that direction. So picture them with forces going in 2 directions, right? Going opposite sides. So do you agree that if I add them together, that they should start pushing me not one way or the other, but in a direction that they're both influencing? Does that make sense? So check this out here. Oh, I guess we'll get to that in a second. Here they just want to know, find negative V. So negative V would just be going in the opposite direction. So negative V is just the same exact arrow. Actually, I think I have arrows I can use. Negative V is just going the opposite direction. Negative U would be this way. Okay. So if they ask you, okay, what's the answer visually, you would just say, here's the original, here's negative V. Okay. Nothing crazy, right? This is the next part. So, well, here's V. What happens if I multiply V by 2? Well, you're going to double the magnitude, meaning length, right? Magnitude is length. So if I double that, it'd be just twice the size, right? Something like that. So just find it. There it is. V times 2. Any questions on those 2 so far? Do you see how it works visually? Okay. This is what I was talking about earlier. If you add 2 vectors together, they're basically going to take you to a new path. It's not going to be just the V or just the U. It's going to be in a co-path, I guess, for lack of a better word. So let's look at the answer so you can see what I'm talking about. So they're asking me, what is U plus V? Get my little arrow thing again. So here's the U plus, sorry, the V plus the U. Okay. That's an easy way to explain that. So they use this thing called a parallelogram rule. Okay. Let me see if I can find it for you. Give me one moment so I can give you a better example. Where is the book? Radical. The wrong book. Okay. Vector operations. Okay. This is the easiest way, I think, to understand the addition, the geometric addition of vectors. In other words, doing it visually, right? Because adding the vectors together, like analytically on paper, you're just adding numbers. Super easy. You add the i's and the j's. You're done. Then you can just draw it. But if you're doing it visually, geometrically, I should say, this is what I want you to understand right here. Okay, so yeah, the parallelogram law. Where is my writing thing? Okay, so what you do is you take the first one because you're doing u plus v. So you take the u, right? And then you put the tip of the v right on top of it. And then basically the kind of like a hypotenuse that is formed right here. That's going to be the u plus v. Okay. So I'm going to just take a screenshot of that so I don't forget. Dang it. All right. Let's see if I can put it in here too, maybe. Doubt it. But... Oh, I could probably send it to you through the chat. Sorry, I haven't checked my messages today or emails, so I will soon. Okay. Give me a second. That way we all have it. So I sent it to the remind. Let's go back to that question so we can do it now that we have the notes with us. Eight point three. There we go. Okay, so let's not look at the answer right away. So according to our notes, that's wrong. That's a stamp. Into our notes, we take the first one, so u plus the v, and then the hypotenuse that is formed is our answer. Okay. So here is the direction we're going. Right, so that's correct. So we take, so one more time. Take the original u, and then we connect the v here. And that's our summation, u plus v. So just pretend you just move them around and connect them. So on paper, draw it, connect the tip of the first one to the tail of the second one, and then draw a hypotenuse, and that is the parallelogram rule. Okay, and that's what I sent you in the remind, in case you forget, because sometimes I forget which one's first. So U is the tip, V is the tail. Connect the hypotenuse, that is U plus V. Okay. Any questions on that? Of course, there's minus, which is just opposite. Okay. All right, example 3, or at least on paper, example 3. This is a problem, I think it's 18. Find U plus V, U minus V, and 3U minus 5V. And this is the V and U that they give us. And if you prefer the other notation, this would be 3I plus 2J. This would be 2I plus 4J. Oh, let me chase like that. Okay. All right, so part A, u plus v. So I showed you how to do it geometrically. U plus v on paper here, analytically, is just add these pieces. They're easier to do if you have it in this notation. So just add the i's together and the j's together. So that'll be 5i plus 6j, which is the same as 5 comma 6 in this notation. B, if we use the other notation, just for the practice, doesn't matter. I don't care which one you use, it makes no difference to me. As long as you do things correctly, you'll be good. You could simply just do this. 3 minus, so u minus v. Take the I of the first one and the I of the second one, the j and the j. So that will be 1 comma -2, which is the same as a single I minus 2j. So see how I can use either one, it doesn't really matter. Okay. All right. C. 3u minus 5v is going to equal 3 times this vector. So I'm going to leave it in the ij component. 3i plus 2j minus 5 times the other component, the other vector, in 2i j component. There you go. So multiply it out. So whenever you see 3u and 5v, that's called a scalar. So you're taking the u and scaling it by 3. You're increasing it times 3. The magnitude, the size, all that. So all you got to do is multiply the components themselves by that number. So that'll be 3 times bigger. This is going to be minus everything. So minus 10i minus 20j. So 9 minus I, that's going to be, so get them all the i's together, all the j's together. And that's it. So negative I 6 minus 20, it'll be minus 14j. In the other notation, that is -1, -14. Okay. Any questions on example 3? Okay. Yeah, I think the next, well, that's fine. Right, you guys, I'm assuming you guys are cool there. We're almost done here, just almost out of time actually. Example 4, find the unit vector in the direction in the direction of V. Okay, I think this is 23. So a unit vector is just a formula. So if they give you some vector V, 3 comma -4, the magnitude of V is going to be necessary. So let me write the formula first. So to find a unit vector of V, divide V by its magnitude. Okay. So here is the unit vector formula. So U, we're going to use the notation U for the unit vector. So you take V, divide by the magnitude here. Sorry, I'm a little out of it. Maybe it's too much math in one day, but the magnitude that we did not find, I just went ahead and put it in there. That's not cool of me to skip steps like that. So magnitude, we said you just square root each component, right? Squared. So that will be this. So I didn't find that earlier. So that's where this came from, the 5. If you divide each piece, you're going to get this, right? This is basically a scalar. So this is the unit vector. And all that means is you shrink down whatever vector we're talking about into a length of 1, and that represents the original. That's it. Okay. Any questions on 4? Okay. Well, we'll stop here because this is a lot for today. I do apologize about yesterday and tomorrow. We'll continue on Thursday. Okay. Try your best to keep up and let me know if you have any questions or issues. I don't want to. I mean, if you're struggling or need anything, tell me soon. We're almost out of time. Okay. All right, guys. I'll see you Thursday.